Hello, young mathematicians. Welcome to lesson 15 in our measurement unit on area and perimeter of rectangles. In this lesson, you will be able to express the formula for the area of a rectangle using variables, use a formula to calculate the areas of rectangles, and we'll investigate how perimeter and area are related to but not dependent on each other. So this is a real basic review of an array. We have 4 rows, 3 in each row. There are 12 dots altogether. Now, if you draw a rectangle on your graph paper, it is very much like an array. So here we have 4 rows. Here we have 3 in each row. And so we would do the same thing. 4 times 3 is equal to 12. There are 12 squares inside this rectangle. This is what we call area. Now, the rectangles that you may be dealing with may not necessarily be on graph paper. You may just be told that it is 50 squares long, 30 squares wide, and then asked what its area is. So same thing, you would take area is length times width. So we would simply do 50 times 30. And if you remember the little shortcut, 5 times 3 is 15. There is a 0 here and a 0 here. So your total area would be 1,500. So we just went over the formula for area. It's length times width. Here we have a length of 10 centimeters. Here we have a width of 5 centimeters. And so if we do 10 times 5, we get an area of 50. And we call them centimeters squared or square centimeters. So centimeters with a little 2 beside it. So pause the video and try these exercises out, and then come back when you are ready. For A, we have an area of 20 meters squared. For B, it's 42 meters squared. 6 times 7 is 42. And I can use my little trick. 2 times 15 is 30, plus the 0 from the 20 makes 300 square centimeters. Few more for you to try, just simple multiplications. Pause the video, come back when you are ready. 2 times 50 would be 100. And then I have the 6. 2 times 6 is 12. So I add those up. We have 112 plus the 0 from the 20 makes 1,120 centimeters squared. 42 times 42, I'll do a multiplication like this. Let's do 2 times 2 is 4, 2 times 4 is 8. Remember to add that 0 in the second row. 4 times 2 is 8, and 4 times 4 is 16. I add them up. I get 4, 16, 7, 1. So 1,764 meters squared. Find the area and perimeter of each rectangle. Well, the first thing you're going to have to do is find the length and width of each rectangle. So pause the video, find the length and width, and come back when you're ready. Okay, so I have the lengths and widths of all my rectangles. I remember that area is equal to length times width. So here I have, remember these are supposed to be 1 meter long sides. 6 times 4 is 24 meters squared. 5 times 5 is 25 meters squared. 3 times 6 is 18 square meters. 1 times 9 is 9 square meters. And 3 times 8 is 24 square meters. Perimeter is when you add up all the sides. So you add up length plus width plus length plus width, because each rectangle has 2 lengths and 2 widths. So the opposite sides are the same. So this side is 6 and this side is 4. So for rectangle A, we simply add 6 plus 4 plus 6 plus 4, which would be 20 meters. These are not meters squared because we're not counting how many of these little squares there are inside, like in area. We're counting, like if we were building a fence around this rectangle, we're counting how long that fence would be all the way around my rectangle. Okay. So 5 plus 5 plus 5 plus 5, which is basically 5 times 4, is equal to 20 as well, meters. Another way to do perimeter would be to do 1 length plus width, and then you just multiply that by 2. So 3 plus 6 is 9, times 2 is 18 meters. 1 plus 9 is 10, times 2 is 20. Whoops. 20 meters. And 3 plus 8 is 11. 11 times 2 is 22 meters for that perimeter. Okay. So list the rectangles from least to greatest by area. C, A, E, and B. And by perimeter, we have 18, which is rectangle C. We have 20. We have 3 20s actually, which is rectangles A, B, and D. And 22 is the biggest perimeter, and that is rectangle E. So you could see that the areas and perimeters, when we list them from least to greatest, they are not the same. So they're kind of independent from each other. So just because a rectangle D has the smallest area doesn't mean that's going to have the smallest perimeter. You can see it's got the second largest perimeter actually. So perimeter and area are related to each other, but not dependent on each other. Draw 2 rectangles that have an area of 10. So think of 2 multiplications that make 10. You can make 2 times 5. You can make 1 times 10. So a 2 by 5 rectangle would probably look something like this. And a 1 by 10 would be a long and skinny rectangle that would look something like that. What are the perimeters? Well, this one will be 5 plus 2 is 7, double that is 14. And so 14 centimeters. And here we would have 1 plus 10 plus 1 plus 10. So that would be 22 centimeters. So you see they both have the same area. Whoops. Same area of 10 square centimeters, but different perimeters. If you have 2 rectangles with the same areas, you will always find that the longer and skinnier one will always have a bigger perimeter, and the one that is closer to a square will have the shorter perimeter. David wants to fence a rectangle flower bed with an area of 36 meters squared. Which dimensions will give him the least perimeter of the flower bed? So to solve a problem like this, I like to think of all the multiplications I can think of that will make 36. So 1 times 36, 2 times 18, 3 times 12, 4 times... 4 times what? 8. Right? 2 times 8 is 16, 32. No, sorry. 4 times 9. And then 6 times 6. So these are all the different rectangles we can make with the length, and so these would be like the lengths and widths, right? Length of 36. Width of 1, and so on all the way down. Okay? Which dimension will give you the least perimeter? Well, why don't we get the perimeter of the two extremes? So the first one, and then we'll also get the fifth one, okay? So the perimeter, just change my color here. Perimeter of this one would be 1 plus 36 plus 1 plus 36. So the perimeter would be 72, 73, 74 meters. And this one, the 6 by 6 one, would be 6 plus 6 plus 6 plus 6, which is essentially 6 times 4, which is 24 meters. So kind of what I talked about before, if the areas are the same, which they are, because 1 times 36 makes 36, and 6 times 6 makes 36. So the areas are the same. The one that's the long and skinny one, which would be this one, width of 1, length of 36, will always get you the greater perimeter. And this one is exactly a square because it's 6 by 6. So the one that's the long and skinny one will always give you the longest perimeter. And the one that's closest to a square, or exactly a square, will get you the shortest perimeter. That's it for our lesson today. Please work on pages 126 to 128 for next class. Good luck.